Namaste. Welcome to 9 students for Samveda e-learning program. Children, here you can see there is an animation. In this animation, you are observing certain spheres. These spheres are representing atoms and these spheres are joined by bonds. When the atoms join by bonds, they form molecules. So, in today's session, let us learn about the chapter Atoms and Molecules. Children, this is the third chapter of your textbook which runs between the page number 31 to 45. Let us now know what are the learning points of this chapter. Here, I have given an animation which shows that some spheres are moving. They are nothing but the atoms and its structure. Let us know the learning points of the chapter. In this chapter, we will learn about contribution of ancient philosophers, laws of chemical combination, we will learn about atom, its definition. We will also learn about symbols of elements and we will learn about size of an atom, atomic mass, what is the definition of a molecule and what is an ion. We will learn about that also in this session. Writing chemical formula. Then in this chapter we will also learn about molecular mass, formula unit mass and about mole concept. This chapter is divided into 3 sessions. Today we are in the first session of the chapter. Children, let us know what are the learning points of this first session. In this session, we will learn about contribution of ancient philosophers, what is an atom, laws of chemical combination which include 2 laws. One is law of conservation of mass, law of constant proportions, and we will also learn about a small introduction to symbols of elements. Let us move for our discussion now. Children, let us now understand about history of atoms and molecules. Our ancient philosophers were always curious to know about unseen and unknown particle of the matter. So, what were the contribution given by them? Let us know them now. It was Maharshi Kanada, an Indian philosopher. Around 500 BC, Maharshi Kanada has given an idea about the atom. He said that on dividing the matter, which is called as padarth, we shall get smaller and smaller particles. Those smaller particles, he said it as paramanu. The smallest particle which cannot be further divided, he said it as paramanu. Later on, another Indian philosopher called as Pakuda Katyayama, he elaborated the doctrine given by Maharshi Kanada, said that particles exist in combined form. Simultaneously, even in the Greek philosophers have also given their ideas about atoms and molecules. Let us know what are those ideas. Children, can you identify him? He is a Greek philosopher called as Democritus. Democritus and Leucippus named indivisible particle of matter as atom, which means indivisible. So, at the earlier time, it was Greek and Indian philosophers has given their philosophical contribution to the history of atoms and molecules. But these were only the philosophical contribution, no experimentation was done by them. Let us now know much about these atoms and molecules in detail. What is an atom? To know what is an atom, I will show you a picture. Children, you can see a picture here. Can you identify what is this? Yes children, you have guessed it right, it is an anthill. What the anthill is made up of? Anthill is made up of minute particles of sand grains, right? Sand grains and soil particles are used up in making the anthill. Now, I will show you another picture. What is this picture represent? Yes children, you have guessed it right, this is a building. Mason, while constructing the building, he uses many bricks. So, bricks makes up the building. He constructs one room and group of rooms makes up the building, right? Similarly, here bricks are the building blocks of the building. Similarly, even it is the same with the atom. Atoms are the building block of the matter. Let us know how can we define the atom. Atom can be defined as smallest particle of an element that can exist independently and retain all its chemical properties. It can exist independently, but it is the smallest particle of the matter. Children, now let us learn about laws of chemical combination. What do you mean by this chemical combination? Chemical combination is nothing but elements combine to form the compounds. When they combine to form the compounds, they follow certain laws. Let us know what are the laws of this chemical combination. Joseph Louis Proust. Here is a picture of Joseph Louis Proust. He is a French chemist. He proposed laws of chemical combination along with Antoine L. Lavoisier. Antoine L. Lavoisier. He is Antoine L. Lavoisier. He is also a French chemist. He done vast experimentation to propose laws of chemical combination. Let us now know what are those laws of chemical combination. The first law of chemical combination is law of conservation of mass. What is this law of conservation of mass? To know about the law of conservation of mass, let us do a simple activity. Here, video of the activity is given to you. Please watch the video and try to understand law of conservation of mass. Materials required: weighing balance, conical flask, cork, a test tube tied with the thread, measuring cylinders, copper sulfate solution, sodium hydroxide solution. Using measuring cylinder, measure 5 ml of copper sulfate solution and pour it to the test tube tied with the thread. Using another measuring cylinder, weigh 10 ml of NaOH and pour it to the conical flask. Place the copper sulfate solution in a test tube inside the conical flask and place cork upon the reaction mixture. Apparatus containing reaction mixture has to be placed on the weighing balance and note down the weight. Now mix the reaction mixture and wait for the reaction to complete and look at the weight of the products formed. You can note that mass of the reactant is equal to the mass of the product. You can even notice that the reaction has taken place in the apparatus. You can find the formation of precipitate at the bottom. By looking at the activity, you might have understood what the law of conservation of mass is. Let us try to look at the statement of this law of conservation of mass. It states that mass can neither be created nor be destroyed in a chemical reaction. That is, whenever a chemical reaction is taking place, The reactants involved in the chemical reaction are modified to form the products, but nowhere the mass of the reactants is lost. Law of conservation of mass can also be expressed as mass of the reactant is equal to the mass of the product. So, in any chemical reaction, how much ever the mass of reactant is taken, that is retained as the mass of the product. But during the chemical combination, there is breaking and making of bonds. There is another law under law of chemical combination, that is law of constant proportions. What is this law of constant proportions? Law of constant proportion states that in a chemical substance, the elements are always present in definite proportions by mass. So, in any chemical substance you take, elements are always present in definite proportions by mass. Let us try to understand this with an example. Children, here a molecule is given. You can find here oxygen is there and 2 hydrogen atoms are there. What does this make up? It makes up H2O, right? What is H2O, children? H2O is water. In the molecule of water, there are 2 hydrogen atoms and 1 oxygen atom, right? So, in terms of number of atoms, if we consider the ratio of hydrogen atoms to the oxygen atom will be 2:1. This is in terms of number of atoms. You take water from any source, whether it is from sea, ocean, river, lake, whichever be the source of water, in every water molecule, 2 hydrogen atoms and 1 oxygen atom will be there. Let us now understand in terms of mass of atoms. Here also water molecule is given. 2 hydrogen atoms are there, 1 oxygen atom is there. Children, hydrogen atom weighs 1 gram. As there are 2 hydrogen atoms, there is 1 gram of hydrogen atom each. Oxygen weighs 16 gram. So, if we want to express mass of the atoms present in the water molecule, it is expressed as 2:16, which when simplified is 1:8. That is, the ratio of mass of hydrogen to the mass of oxygen is always 1:8, whatever the source of the water. This is what law of constant proportion says. To this, experimental evidences of Anthony Lavoisier and Joseph Proust, a theoretical explanation was given by a scientist called John Dalton. John Dalton, he is an England chemist. He began his career as teacher. He worked as teacher in 1793 at Manchester. In 1808, he proposed his ideas about atoms and molecules as Dalton atomic theory. Let us know what is this Dalton atomic theory. What are his ideas? There are 6 postulates under Dalton's atomic theory. Let us understand one by one. The first postulate of Dalton's atomic theory states that all matter is made up of very tiny particles called atoms. Here a picture is there. In the picture, spheres are there. These spheres represent atoms. So, any matter you take, all the matter are made up of tiny particles called atoms. Second postulate says that atoms are indivisible particles which cannot be created or destroyed in a chemical reaction. Children, look at this postulate. Are you finding it insimilar to one of the law of chemical combination? Yes, children, you have guessed it right. It is supporting to the law of conservation of mass. So, Dalton's atomic theory, though it was theoretical, it supported to the ideas of Antony L. Lavoisier and Joseph Proust. The third postulate of Dalton's atomic theory states that atoms of a given element are identical in mass and chemical properties. You take atom of any element, they will have identical mass and chemical properties. Let us see an example here. Here I have given a picture of iron ball. In this iron ball, iron atoms are there. Another picture represents iron chain. Iron chain is also made up of iron atoms. In both we find presence of iron atoms. Is there any difference in the nature of the atoms present in iron ball and the iron chain? No. In both the materials, iron atoms are of same mass and have same chemical properties. So, whichever the material is, a given element will have identical mass and chemical properties. Let us now go for the next postulate of Dalton's atomic theory. It states that atoms of different elements have different masses and chemical properties. For example, here an image of gold biscuits are given, and here an image of copper vessel is given. Gold biscuits are made up of gold atoms. Copper vessel is made up of copper atoms. Is there similarity between the gold atom in the gold biscuit with that of copper atoms in the copper vessel? No. Copper atoms have different mass and gold atoms have different mass. Properties of copper atom is entirely different from that of gold atom. So, atoms of different elements have different masses and chemical properties. Now, let us know about next postulate of Dalton's atomic theory. He says that atoms combine in the ratio of small whole numbers to form compounds. Whenever atoms combine to form compounds, like hydrogen combine with oxygen to form water molecule. When they are combining, they combine in definite whole numbers. For example, as in case of water, two hydrogen atoms combine with one oxygen atom to form water molecule. We won't find the presence of half hydrogen atom combining with 1/4 of oxygen atom to form water molecule, right? Always atoms combine in whole numbers to form compounds. Now, let us know sixth and the last postulate of Dalton's atomic theory. He says that relative number and kinds of atoms are constant in given compound. You take any compound, number of atoms and kinds of atoms present in that compound will be same. Let us understand it with example. Here we find water in different forms. Water as ice is there. Second picture, water as liquid. Third one, boiling water where it is converting to vapor. In first one, water is as ice, solid form, whereas in second one, it is in liquid form. In third one, it is in gaseous form. In all these three forms of water, water molecule is H2O only. Two hydrogen atoms combine with one oxygen atom to form H2O. Though the form of water is different, number of atoms and type of atom of water molecule is the same. This was one of the postulates of Dalton's atomic theory. In all these 6 postulates, he has supported to the ideas given by Joseph Prost and Antony L. Lavoisier. Let us now understand about symbols of elements. What do you mean by symbols? Symbols are nothing but shorthand representation of particular element. Children, can you identify who is he? Yes, you have guessed it right, he is John Dalton. Again, he has contributed to the symbols of elements. He was the first scientist to use symbols for elements in specific sense. Let us now see what are the symbols given to the elements by John Dalton. Here, a picture of symbols of different elements given by Dalton is there. You can see in the picture, hydrogen element is having a symbol with circle and a dot in the center. In case of carbon, you can see a circle which is little shaded. Whereas for oxygen, it is a empty blank circle is there. And for phosphorus, we have circle with 3 lines. For sulfur, circle with square shape. For iron, circle with I written in the center of the circle. In this way, Dalton has given symbols to some of the elements known at his time. He has not used any particular rules for giving the symbols, but he has given pictorial symbols to some of the elements at his time. Later on, a scientist called Berzelius, he has given further idea about the symbols of elements. He said that symbols of the elements can be taken from the name of the element. First 1 or 2 letters from the name of the element can be considered as symbol of that particular element. Now, we have an organization called IUPAC, which means International Union of Pure and Applied Chemistry. This organization approves names of the element given. Any element has to be named should be approved by IUPAC, an union to approve the names of chemical compounds. From our understanding, let us go for the quiz time now. Let us try to answer some questions based on our understanding. First question, a sample of NH3 molecule. Children, NH3 means ammonia. A sample of ammonia molecule, irrespective of source, contains 82.35% nitrogen and 17.65% of hydrogen by mass. This data support. A data is given here. Ammonia molecule is having nitrogen with 82.35%, hydrogen with 17.65%. With this data, what do you understand? You take ammonia from any source. Percentage of nitrogen and hydrogen is constant. What is this represent? Law of conservation of mass, law of multiple proportions, law of definite proportions, Avogadro's law. From the data given, we can understand that this data supports law of definite proportions. So, the correct answer is law of definite proportions. Let us go for another question. In a chemical reaction, the sum of the masses of the reactants and the products remain unchanged. This is called, what does this represent? Mass of the reactant is equal to mass of the product. That is nothing but law of conservation of mass. Now, let us go for another question. Atoms can neither be created nor be destroyed during a chemical reaction. This statement of Dalton's atomic theory supports. This is one of the postulates given by John Dalton. What does this postulate support? Option 1, law of conservation of mass. Option 2, law of definite proportions. Option 3, law of multiple proportions. Option 4, Avogadro's law. Look at the postulate given. Atoms can neither be created nor be destroyed during a chemical reaction. Children, did you find the answer? Yes, you have guessed it right. The correct option is law of conservation of mass. From the discussion that we have till now, let us take some home assignment questions. Children, keep your writing material ready to note down the questions for today's session. Sanvi is doing her homework based on law of conservation of mass. She burnt fixed mass of wood and weighed the ashes left behind. She found that the total mass of the reactants and the products were not equal. Does this violate the law? Why did she find the difference in the masses? Explain. Note down the question. Okay, hope you have written the question. Let us go for the next question. Second question. State two laws of chemical combination. Two laws are there. First one, law of conservation of mass. Second one, law of constant proportions. You should give the statement of these two laws. Third question, what are the features of Dalton's atomic theory? From our understanding, we know that there are 6 features of Dalton's atomic theory. You should list down those 6 features of Dalton's atomic theory. Children, hope you have understood the concepts of today's discussion. Please write answers for these questions, discuss with your friends and get it corrected from your teacher. I am Kruti Hegde, working as assistant teacher at Aadarsha Vidyalaya, Tatikalu. Let us meet up again in the next session. Thank you for your patience listening.